So as far as the 14 segment display goes, right, I've got so it's a common anode, right, and we've got 8 different anodes on it, okay? So the way this is broken up, you've kind of got your main 7 segment display sort of segments, except that instead of having just one G bar that goes across, it's broken into G1 and G2. Now G1 is controlled sort of with the main cathode sort of group, right? You got 2 groups. You got the main, and then I don't know. I call it the auxiliary. I have no idea what it would normally be called, but G1 is part of main. G2 is part of aux. Okay, so the auxiliary ones are G2, and then these inner ones that sort of make the 14 segment display the 14 segment display, right? Now I've got basically, this is the entirety of the characters that I wanted to be able to display. I believe I've got them all here. I may have added a couple more later on in here, but this is sort of how they are displayed. Now I added the slash and the 0 just because, I mean, I've done it since one of my teachers did it, and I don't know, I guess I wanted to be like him, so I started doing that. And also, if you're going to have an O, you might as well differentiate it from a 0, especially in something that's as ambiguous as a 14 segment display, right? Like, so anyway, this is how it's all broken down. Now, because it's common anode, not common cathode, you are going to light these up by providing a path to ground, right? So the way that I'm doing that is basically just by syncing current with the EEPROM, okay? So when I'm decoding with the EEPROM, a 0 is effectively a 1 in the sense that it's turning it on, right? So that's why this seems like the opposite of what it should be, right? Now, the way that I'm doing mine, this topmost bit here is the reset, which when this flips to 1, it basically signals the end of the scrolling, or the end of the text. Okay, so if I've got like a phrase that I want to display, I will end it with this ASCII end of transmission character or whatever, right? So it starts with main and then it goes to aux. So at the end, I don't know that it matters, but I wanted the timing to be sort of the same, I guess. So aux of end of transmission is a 1. So when this is a 1, that can basically just be connected to the reset pin of the counter or whatever, right? And so that by using this, I can use the end of transmission ASCII character to signal the end of the phrase that I'm displaying, right? Now, I'm converting it to hex here just because it's easier to write it in hex. When I was I basically bit banged the entirety of this right into the EEPROM. So that's why that's there. Now, the address here, you'll see, is there's 2 per character, right? And that's because we've got the main and the auxiliary, right? So we've got 2 addresses that are applicable to any given character, right? So the reason that it's 0 and then 8 is simply because I'm flipping the topmost bit of the address, and if I'm not mistaken, 8 in hex is 128, right? In decimal, which is what happens when you, well, I mean, that's the place value of this top bit, right? So anyway, yeah, so that's why this is like this, and it goes down like that. And then the way that I'm going to control the 14 segment displays, so I'm gonna have 12 characters, right? Because there's 3 4-character 14 segment display modules or whatever, right? Now, I'm gonna have a pointer to that first place, okay? And sort of as far as the computer is concerned, that's the character that we're on. And so then, and that's gonna be a memory address in the RAM that is storing what I want to display, right? So not this, the RAM that I'm storing my phrase to display in, right? Now, that's going to have a character, right? Obviously an ASCII value. And so by connecting that out, right, to the EEPROM, that's how we're going to be selecting an address from the EEPROM, and that is what is controlling what is displayed, right? So that's kind of how that works. Now, in order to sort of handle the refresh and the scrolling and whatnot, the refresh logic is basically going through, each digit one at a time, and then it's going main and aux, main aux, main aux, main aux for each digit, and displaying, whatever the appropriate combination of segments is for the character in question. And then when it reaches the end, it goes back to the beginning, okay? But that doesn't scroll the text. That's just going to display, 12 letters, right? And so in order to scroll the display, we increment the pointer, which is of course, that's the memory address of the first character, right? So by incrementing that pointer, now all of the text shifts over by one digit, right? So this one falls off, and then we're showing one more in memory. Now, when because the way that this works, right? Yeah, I've got these demultiplexers or whatever that are being used to sort of cycle through all the digits and then all the displays. So when the first digit is active and this reset bit is high, that is going to signal the restart. So by doing that, we make sure that we display the entirety. Like we don't run the risk of when we're trying to scroll text, it just stops in the middle and starts over, right? Because that would just kind of look stupid. So that's the purpose of that. But the one caveat with that is we have to initialize the memory to be all blanks, okay, or spaces or something to that effect, right? Otherwise you get random crap that's going to get displayed, which is even worse than it just restarting in the middle. So that's the logic with that. Now, the pinout that I've got with this display here, okay, is now this is the pins of the thing. Now there is a pin 7 here, but I snipped it. Now I don't know if that's going to cause problems, okay, and I'm far from knowledgeable on electricity, but I believe you can have inductive coupling or whatever is what it's called, where basically when you're flipping around power on one of these two bits or whatever's closest to it internally, we may end up inducing current in that pin, okay? And because that is I believe it's an anode, whatever is connected to ground elsewhere could basically, this pin controls the decimal point and the colon. Okay, so basically, I guess what I'm saying is we could have weird flickering of that. I don't really know if it's gonna happen, but that's why we're missing a pin here. I just wanted to test it. And if it does, I'm probably gonna try just blowing it up by connecting it without a resistor. And then if that doesn't work, I'm gonna try tying it to one of the cathodes just to see if that somehow fixes it. Anyway, but what I wanted is I want basically all the anodes on one side and all the cathodes on the other side, right? Now, I'm having all the cathodes on the bottom because the EEPROM's over here on the breadboard, and so we're gonna have the wires then come up over here, and then we're just gonna kind of daisy chain them along. So yeah, and then up here is our anode, and it's in this order here. I kind of ran out of space because I'm retarded, but aside from that, that's the order right here. Okay, and this order is in order of like appearance here, not in terms of like the pin number or anything. Now, the way that I'm doing this, right, is because we need something to limit the current, and so I'm connecting the cathode of any given cathode pin to the EEPROM through a 220 ohm resistor, okay? And so that's how we're controlling the current, because if we just connect it directly, then it's gonna blow up, and that's considered bad. So we're gonna try to avoid that. The anodes, obviously we don't need to add resistors on. So yeah, and the reason you don't wanna add a resistor on the anode is because then the brightness is gonna change depending on how many cathodes are active, so yeah. Now, here's our pins on the bottom here, okay? These sort of purplish ones, the reddish purple, these DCs, these are don't connects, because if you connect those to ground, everything blows up, which is again considered bad. So And then the NCs, these are no connect. I mean, in theory, you could connect them. It's just they're kind of flopping over to the other side and connecting here. So, you know, questionable decision to hook it up here. But yeah, then, so we've got the main and the aux of, this is the value of any given pin. And then this is the EEPROM IO pin applicable to this, you know, whatever section of the segment it is in fact applicable to. So, and then that's the line up here. And you can see the main, the aux, and so on. So anyway, I will upload these onto the GitHub just in case they're useful to anybody. But yeah, that's the plan for the 14 segment display. So pretty cool.